Hi, this is Aaron Jerome again from Jerome Electronics. This is going to be my last series, or last in the series of number systems. This is going to be a super short video, probably my shortest ever. But it is a separate topic that students need to know about. Again, thank you to mycockpitview.com and Necessary Disorder for these great graphics that I borrowed. And this time we're going to be talking about Part G in the Intro to Number Systems, BCD, or Binary Coded Decimal. You're listening to Lay My Love by John Cale and Brian Eno. And let's talk about binary coded decimal for a minute. This image actually illustrates why we're eventually going to need binary coded decimal. I'm kind of going into it with my students a little blind. I'm telling you what binary coded decimal is, and then later on we'll get into why it's useful for anything, but here's a hint. Okay. Binary coded decimal, BCD. Basically, binary coded decimal, remember you're writing the red words in your logbook, your engineer's notebook. It uses a 4-bit binary number, which we have defined as a nibble. Remember, you can either take a bite of a cookie or half a byte, which is a nibble. 4 bits is half a byte. So we're using a 4-bit binary number to represent each of the 10 decimal symbols. You already know what these symbols are. So we're going to take 0000, that's going to be a 0. And of course, that's a 1 and a 2 in both systems. There's a 3 and a 4 and a 5, 6, 7, 8, 9, and that's all. That's all there is in binary coded decimal. Just 4 bits that represent a value that is a decimal value only. So if you need to pause the video, pause it here to write these things down, or I'm just going to continue on. Okay. Now, the whole point of binary coded decimal is that we're representing these decimal symbols with binary numbers. The numbers appear to be binary, but there are only 10 of the numbers, 0 through 9. The following numbers in binary coded decimal are impossible then, because they represent values that are greater than 9. So values that are greater than 9 are not allowed as part or to be called binary coded decimal. This is a decimal, or this is a binary 10, 11, 12, 13, 14, and 15. These are not binary coded decimal numbers, but they look like them, so they can be a little bit confusing. All other binary numbers require more than 4 digits, and they are also impossible in binary coded decimal. That's because they're all bigger than a nibble. Okay, so let's try some binary coded decimal. Here is a nice 12-digit number. It's a binary coded decimal number. In a binary coded decimal, you set up the column weights like this. Then you simply convert them. So 4 plus 2 is a 6, 4 plus 2 plus 1 is a 7, and the last one is a 2. That was pretty easy. This binary coded decimal with 12 digits is the same thing and represents the value of 672 in the decimal system. Kind of strange that we would use up so much energy to use more digits rather than fewer. In any case, here's how to mess things up real bad. Don't confuse binary coded decimal for binary. Here's how students make this confusion, how they get confused. They say, in binary, not binary coded decimal, these are the place values. And if you try to convert a number using these place values, it will not be a binary coded decimal result. This actually happens to be 64 plus 32 plus 16 plus 2, which is 114. On the other hand, if you set the column weights up correctly, you get these, which is a 72 in binary coded decimal. So now I've taught you how to make mistakes. Don't make mistakes. Okay, so here's solving another way. Let's take the decimal number first and convert it backwards to binary coded decimal. That just means for each one of the numbers, you're going to need a set of nibbles. Then you will spread the number out under its representing nibble and then just basically convert it to binary. You can cast the place values to help you if you want and then convert from decimal to binary coded decimal. Well, 8 plus 1 is 9, and 4 plus 2 is 6, and 4 plus 1 is 5, and that is how you convert backwards from decimal to binary coded decimal. Okay, let's try another one. What number is this? I'm just pausing. I probably ought to have paused the video, but that first number is a 14. That is not a binary coded decimal number. This is an 11. That is too big because it's not 0 through 9. This is a 13. This is not binary coded decimal. These numbers are all greater than 9, so what you've really got here is garbage. So be careful on tests and stuff. Don't let these fool you. When we do an assessment and we call something binary coded decimal, but we give you illegal values. Okay? All right. So binary coded decimals, this is the review. This uses a 4-bit binary nibble to represent each of the 10 decimal symbols. And in binary coded decimal, there are no values beyond 9. No nibbles above decimal 9. That's all there is. Thanks for watching. Thanks for watching. If you're this far, chances are you've watched the entire number series. We are going to come back and talk about other things. I've got lots of videos still. It's just this one concludes the number series. So, I'll talk to you next time. Thanks for watching. Jerome Electronics. Bye-bye.